It's that favorite time of yours. In the class, there would be a physical break and then a mental break. Here, there is directly the mental break time. This is a little senior joke, but well, you are already in the 4th year. There is a fabric shop where they sell cloth, right? Not dresses, cloth, right? You go there, you buy cotton or silk or this and that. Then you take that material, that fabric, to the tailor, and the tailor does the dresses for you, right? So this girl went to the fabric shop and she is looking at different materials. She selects a silken type of material and she asks the shopkeeper, the clerk, that what is the price of this material. Now there is nobody else at that time in the shop, and this is quite an attractive girl, and the shopkeeper, the clerk, sales clerk, is a young man, so he tries to be a little cheeky. He says that it is 1 kiss per meter. What is the rate? 1 kiss per meter. Now the girl, rather than getting angry or embarrassed or so on, said, okay, I agree to the price. Please measure out 5 meters of this silk for me. The sales clerk is very happy. He did not imagine that this will turn out like this, and he starts to measure 1 meter, 2 meter, 3 meter. By this time, an old man, 60-65 years of age, enters the shop, and he's near the girl, near the counter, and the girl says to the sales clerk that my grandfather was parking the car, now he is here, so he will make the payment to you. Break over. Right, so we were just doing the different parts and structure of a sand mold. Now, before we go again to the fluid mechanics part of sand casting, some terminology, some major terms that are there. Pattern. It is the approximate duplicate of the part to be cast. You see, you have to make a mold or a die in which the metal, molten metal, will be poured. But how will you make the mold? So first, out of metal or wood or some other material, you make something called the pattern. You make something called the pattern. This is almost exactly the same size as your final product, almost. And using this pattern, you make the mold. Inside the mold, you make the mold cavity, and then you use it. Okay? Of course, the pattern cannot be exactly the size of the final casting, because there will be some shrinkage. Hot metal, when cools, will shrink a little. So the pattern should be a little larger than the actual size. And then there will be some finishing allowances, right? Once you take the casting out, then you may have to do a small amount of machining to get the exact dimensions and so on. So the size of the pattern is very critically calculated to allow for shrinkage allowance of that metal and for finishing allowances and so on. And pattern making is a major art. Very senior die design engineers usually are working in the pattern shop. I have worked in an industry where a lot of casting was there, so there was a big foundry, and I did not directly work in the pattern shop, but I interacted with those guys quite a bit. They are brilliant engineers. Then of course the molding material, the material that is packed around the pattern to provide the mold cavity. In a sand mold, the molding material is sand, and there could be other materials. Flask, you know. Cope, you know. Drag, you know. Core, I told you, the sand or metal shape that is inserted into the mold to create internal features like holes and so on, right? So please read through these definitions. I have already explained the flask, the cope, the drag, the core, and so on the drawing when we were doing the structure of the sand mold. Mold cavity is the place where the cavity for the mold is there, right? Riser, I have told you. Gating system, I have told you. Pouring cup, sprue, runners, gates, right? So we are now writing out the definitions, but you already know, we have already discussed it, so you can read again and go back to the figure and compare again your notes and try to understand. As I keep on reminding in all of my courses, I am very much against, I dislike the word memorize. Doctor, do we have to memorize this? I absolutely seriously dislike it. But the thing is that if you pay a lot of attention and try to really understand something, then it is already there in your mind. And when you carefully revise it at least once, then with understanding, the memory is almost there. You don't have to memorize. So memorizing is by rote, by you repeat so that you memorize without really understanding it. Then very quickly it goes away. But memorization through understanding is not really memorization. You understand something, and with serious understanding you repeat it once or twice, and then it is permanent. Parting line, you know, right? Parting line, you know. Again, we are showing the cope and the drag and the whole flask, and this center line above and below which is the cope and the drag is the parting line. Then draft is something new. Draft, angle or taper on a pattern that allows for easy removal of the casting from the mold. You see, the pattern will be put inside the sand mold and sand will be packed all around it. But later on you have to remove this pattern so that the mold cavity is formed. So on the pattern walls, you leave a small incline angle. You don't keep it exactly 90 degrees. You keep a small incline of an angle, and that angle you call draft. That is there so that it can be easily taken out of the sand without breaking or damaging any of the mold. And casting is the casting, right? It is the process of casting and it is the final shape. Here it is a two-part sand mold, for example, right? Two-part sand mold. And here it is the core, that if you have to have a hole inside, if this is to be the casting, then first of all, this whole thing will be the pattern. But once you use this pattern and make the sand mold, later on you remove the pattern. So now this whole cavity shape is there. Inside the sand. But there is a hole in between. So you put a solid sand core in the cavity, right? This cavity is created in the sand mold and you put the core in between the cavity. So now when the metal flows, it flows all around in the cavity, but this portion it cannot go into, so later on this becomes the hole, right? So there is a pattern. By the pattern you make the mold cavity, and in the mold cavity, after removing the pattern, you put the core if there is to be a hole or any internal feature, right? So we have described to you the sand mold, and now we have described to you some major terminology that is used. With that, now we come to the fluid mechanics part of it, right? Because you see, we will have molten metal. So this is now a total liquid. There is no solid, it is a total liquid. And then there is high temperature, and through the sprue, you pour it, you let it flow through the sprue, through the gating system, through the runners into the mold cavity, right? So there will be a pressure involved because a liquid is being poured, and there will be a velocity involved, the velocity at which the liquid is going down and going to the runners. So some fluid mechanics and thermodynamics is required. You know, in the fluid mechanics course, you know the Bernoulli theorem, right? Bernoulli theorem. First of all, again, the language part. This guy, by the name of it, is French, right? In French, if after vowels there is consonants, then you don't pronounce it. So it is not Bernoulli, it is Bernoulli, right? This LL is silent because it is French. Second, R in France is between R and R. The city is not Paris. In English you call it Paris. In French you call it Paris, right? So the very correct name would be Bernoulli, Bernoulli. But even if you say Bernoulli, it's okay, right? But I always feel that if words are pronounced correctly, suddenly there is a major impression that this guy is good in language. Secondly, if words of other language, there are some words of Spanish or French mixed, then if you pronounce them correctly according to the French pronunciation, then there is even better feeling about you. So when you say Bernoulli theorem, Bernoulli, then people say, oh, he knows. Otherwise, if you say Bernoulli's, it is still okay. So now you can read through the rest of it, but this is the law or the theorem, you know. H plus P upon rho G plus V squared upon 2G is equal to constant. H is the height of the fluid column, P is the pressure, rho is the density, G is the gravitational constant, V is the velocity, right? And when you say this is equal to constant, then it means that if there is a column of liquid, this place you mark 1, this place you mark 2. So H1 plus P1 by rho 1 G1 plus V1 squared by 2G is equal to H2 plus P2 by rho 2 G2, right? So you just say 1, 1, 1 on one side, you say 2, 2, 2 on the other side, and they will be equal. So if there is a column of liquid or fluid and you are designating one position here, one height, and the other height here, then the sum of all these terms is equal to, right? So therefore you can write H1 plus P1 by rho G plus V1 squared by 2G is equal to H2 plus P2 by rho G plus V2 squared by 2G plus F. Why rho is not rho 1, rho 2? Because it is the same liquid. If it is the same material, then the density of the material is the same, the constant is the same. So there is no 1 or 2 here. But in the height, the position here is different, the position here is different. The pressure there may be different, the pressure here may be different. The velocity at that location may be different, the velocity at this location may be different. And then what is this F? This is the frictional losses, right? A liquid is flowing and it is flowing against some wall. So there is some friction between the liquid and the wall. So because of the friction, some losses are there. So ideally, if there is no friction, then this is equal to this. But if there is some friction, then the frictional losses are there. So this is Bernoulli's theorem. You already know about it. But because here we will have a sprue, that conical shape vertical cavity through which the molten metal will flow down into the gating system and runners, and finally it will reach the. So how should you design the sprue? What should be the diameter? Should it be conical? Should it be straight cylindrical? And all those things are there, right? So this is the Bernoulli's theorem, and you will need it. Then you know the continuity equation. Mass continuity is there. And if you know that if you multiply mass per unit volume, you have density, right? Density is constant. It is the same material. So if there is mass continuity, there is volume continuity. It is the same thing, isn't it? Because mass and density are related through volume. And if density is constant, then if there is a continuity of mass, there will be a continuity of volume. So if Q is the volume flow rate, then volume flow rate is constant. So at section 1, Q is A1 V1. At section 2, Q is A2 V2, right? So this is the volume flow rate, and this is the other volume flow rate, area into meter per square second. So meter cube per square second, volume flow rate. So continuity equation is the next equation. This comes from basic mechanics.